Hello everyone, we're here today at the World Electrolysis Congress organized by World Hydrogen Leaders. My name is Johann Wiebe from the Hydrogen Standard. With me here today stands Kevin Quast from Honeywell. Welcome, Kevin.
Welcome to see you again. This is our second time. It's been like 5 months since we last saw each other, so good to see you again.
Very true, very true. It was very nice to talk to you last time at the World Hydrogen Week in Rotterdam, and here we are again. Right, let's go to it. Honeywell, family name in the business, I would almost say, very well known across the space. Tell us a little bit, maybe actually first a bit of intro, and then we'll move into the business specifically where you're focused on.
Where Honeywell is really involved across the value chain in green hydrogen is really, if you think of from the beginning, where you have syngas and synthetic fuels that are created, all the way to the point where you're having end uses of the hydrogen for things such as the creation of SAF or biofuels, et cetera. We play across that entire space. As we think of what we've been presenting here and what we've been talking about at this conference, the WEC conference, where hydrogen, where we're really involved is in two or three different aspects. One is blue hydrogen and CCUS. So although this is really focused on green hydrogen, we do have a blue hydrogen solution that is actively in the market, and there's press releases on that. Along with the blue hydrogen, obviously you have carbon sequestration because you're using fossil-based fuels to create the hydrogen, and that's why it's called blue hydrogen. But we know that there's going to be a transition away from that blue hydrogen into the green hydrogen over a period of time. Most are predicting around 2030 are going to start seeing green hydrogen come into greater play. In that particular space, we have two products that we're selling. One is around purification. So as you look at the electrolyzers, especially the AEL or the alkaline electrolyzers, you need to have really, really pure hydrogen coming out of those. And in a lot of cases, they need to be purified. So we've got a PSA solution that can bolt on to the back end of an AEL electrolyzer as part of the equipment. The AEL technology that we've had, or excuse me, the PSA technology, the pressure swing absorption technology, has been around for about 50 years. So it's a very well and established technology in the oil and gas and the chemical industry. It hasn't necessarily been applied to the hydrogen production industry, which is now where it can be applied. And so it's a very true technology. It's already been tested. The absorption materials might be a little different than used in other industries, but it eliminates and purifies that, eliminates the contaminants and purifies that hydrogen up to about a 99.9% level, which is really good for a lot of the industries like the chemical industry and semiconductor industry where the hydrogen may be used.
If I can jump into that for a moment, you're talking about some of the downstream industries where your applications are used and will be used. Can you elaborate a little bit on that? Which sort of industries hold a lot of potential in your view? Which ones you're already active in? That sort of stuff.
Yeah, and what you find is with blue hydrogen as well as the future green hydrogen, it's pretty much the same industries. You've got to look at those carbon intensive industries. So really when I look at the five of them, the five that are common between blue and green, the first one is like the petroleum industry and the oil and gas industry. And if you narrowed that down even more, you'd say refining. The other area is steel mills, so the steel industry, and you're starting to see announcements around green steel quite a bit. A couple of announcements one in Northern Europe and one in Southern Europe. The third one is around cement and cement kilns because they're highly energy intensive. The fourth one that we're seeing is different in Europe than it is in the United States. In the United States, we're seeing over-the-road trucking, or what is known as Class 8 trucking, using hydrogen as a fuel. Not our cars and automobiles, it's more the over-the-road trucking. It's a little different here in Europe because your distances between major cities isn't as large, so we're not sure that transition over to hydrogen is going to be as great in Europe as it is in North America. And then the fifth one is kind of an oddball that sometimes you hear about, sometimes you don't, and it's around the data centers. And data centers using that hydrogen as a fuel and potentially battery backup and things like that. But as you start to think about the data infrastructure and the data center infrastructure globally, they're highly energy intensive, and this is a way that they can be carbon neutral and or carbon negative.
And they need to be able to operate day and night, even when the sun is not shining and the wind's not blowing. Hence, hydrogen provides a solution for that.
That's exactly correct. As you start to look at the green hydrogen, what makes hydrogen green? It's because it's using renewable resources, and that tends to be at the wrong times of the day and so forth. And so therefore, you've got to have some sort of battery backup or storage. The other thing that we do in green hydrogen is around our membranes. So the green hydrogen catalyst coated membrane, or CCM, is very differentiated compared to a lot of the competition and what's in the market right now.
Membranes, we'll come to that in a second, Kevin. I had that on the list as well. You're jumping the gun. You're always one step ahead of me. But before we go to the membranes, tell us a little bit about the reorg. So last time we spoke in October at the World Hydrogen Week. Next one coming up in Copenhagen, by the way, for those of you who don't know, this year. But last time we spoke, you talked about Honeywell going through a reorg. Tell us a little bit what sort of changes you've gone through, what's different now, what's your focus? Yes.
Yeah, so the last time we spoke, we had just like 2 or 3 days before we had the event, we went through a reorganization. And it was a pivot towards, I'd call it the new economy. Because as you look at Honeywell and you look at the businesses that we're in, they are all very different, but yet there's some underlying themes and similarities between them. What I have noticed from that 5 months ago or so when that was announced to today is there's a lot more conversation happening across the different main businesses of Honeywell around some of the technologies that we have as an organization. So as an example, as you talk about like green hydrogen and you talk about hydrogen, the aerospace industry is very interested in fuel cells. And so a lot of what we're doing on the green hydrogen CCM side is directly applicable to fuel cell analysis and design and R&D that we're doing. And it's directly applicable to the aerospace industry. And so you're starting to see some of these connections going across. Another one is around when you start to look at our HPS group, which is our production systems and our analog type systems and digital systems. You're starting to now see, and we're starting to have the conversations around, as an example, a company is going to put in multiple electrolyzers. And so there's many, many electrolyzer stacks and many, many of these electrolyzers in a facility. How do you operate each one of those independently, and how do you operate those together as a cohesive unit to know that you've got the right type of balance, load, et cetera? And our Honeywell control system solutions are able to do that. And the other benefit is a lot of the end users of the hydrogen already have Honeywell control systems in place. So these will automatically plug into that existing infrastructure, reducing the infrastructure costs, but also allowing those end users to be able to monitor how the hydrogen is being used, how the electrolyzer stacks are operating and how efficient they are, the water temperatures, whatever it may be. And it just becomes part of their existing control system structure and screens and monitoring that they do.
So, in a nutshell, a lot has happened. And thank you for exploring all the details with us right there. That's all good. So, as you jumped on before, the membrane, let's talk a little bit about that. So what sort of stage are you guys at rolling that out to the market? Yeah, if you could tell a little bit about that, that'd be great.
So, as you may be aware, Honeywell has been involved in, and UOP specifically, has been involved in the creation of membranes for about 40 years. Primarily on the oil and gas side and gas separation and purification side with our Seprex membrane. Well, you know, Honeywell being a smart company and UOP being a smart company, they looked at that and realized that a lot of that base technology and understanding and knowledge could be leveraged in the creation of the catalyst-coated membranes. If you look at UOP, we're one of the world's leaders in catalysts for the refining industry and the petrochemical industry. And so therefore that knowledge of catalysts and how to coat catalysts with materials and precious metals, all of that comes into play when you start to look at the catalyst-coated membranes that enable the electrolyzers to function. It's the heart of the electrolyzers. And so we're involved in two different technologies. One is the PEM, or proton exchange membrane, which is kind of the leading up-and-coming technology for the catalyst-coated membranes. And the other one is AEM, or anion exchange membrane technology, and that's a little bit later on, and it's a little bit still in the kind of R&D phase. Where we're at with PEM is we've done extensive internal lab tests within our R&D facilities, but we've also placed samples and the membrane into the electrolyzer OEMs for them to test independently. And what we have found is significant differentiation compared to what's on the market right now for the PEM CCM competitors. We've got much better hydrogen creation, about 55% greater, with the same current density. We've got about 35% capex reduction that can be done because we're more efficient at the use of that electricity to create that hydrogen. And that's kind of generation one. We're looking at future generations, if it's possible to remove the PFAS portion of the membrane. PFAS is in the regulations over in Europe as well as in the United States. It's forever chemical. Trying to eliminate that, trying to reduce the precious metals, the iridium and the platinum that are used within these catalyst coatings as well as much as we possibly can, and get to the point, if we can, to eliminate those. And so that's where we're kind of on that leading edge with all the knowledge that we have of the 40 years of experience of having created membranes in the past, and leveraging that for the catalyst coated membranes that we're using here to create green hydrogen.
Fantastic, Kevin. I think we covered a lot of ground here. I say we, but particularly you. So thank you very much for that explanation. Kevin Quast from Honeywell, thank you very much.